Hey guys, this is our second video where we're looking at solving trigonometric equations where the angle inside of the function is being multiplied by some number. So here we're looking at cos examples. So this is really a continuation of the sine video, so I'm not going to go over the same stuff that I did at the start of that one. If you haven't watched that yet, go back and watch that first. What I am going to say that's very important is that cos has the same period as sine, so we're going to use that in the same way that we did with sine. So let's get cracking. Okay, for our first example we want to solve 3 cos of 2 theta minus 1 is equal to 0 for theta between 0 and 360 degrees to 1 decimal place. So first thing here, we got a bit of a funny equation. We need to rearrange that to get the cos function on its own. So if we add 1, we get 3 cos of 2 theta is equal to 1, and then divide by 3, we get cos of 2 theta is equal to 1/3. So if we now inverse cos to get 2 theta, we would get 2 theta is equal to the inverse cos of 1/3, which to the nearest, to 1 decimal place is 70.5 degrees. Okay, so we're going to use the same method as before where we change the interval. So we want values of theta between 0 and 360, but we've got cos of 2 theta. So if we multiply that whole interval by 2, we want 0 is less than or equal to 2 theta, which is less than or equal to 720. So if we now sketch the graph of cos of theta, now we're only going to do it between 0 and 360, not between 0 and 720, because we can use the period to our advantage. So cos of theta looks like this, where this would be 360, this is 180, the first x-intercept is 90, and the second x-intercept is 270. So what we do using the changing the interval method, we're going to mark on this first solution that we found, which was 70.5 degrees. So that is going to be over here somewhere. So that's our first value for 2 theta. So 2 theta is equal to 70.5 degrees. Now, before we worry about the second solution from the graph, we're going to get any others that we can from this one using the period of the function. So the next solution from that part of the graph, or the next time that exact part of the graph happens, is 360 degrees later. So we add 360 to 70.5, and that gives us 430.5. Now, if we were to add another 360, we would be outside of our interval for 720. It would be 790.5. So we don't need to add another 360. What we can do now from these two values is divide by 2 to get our values for theta. So 70.5 divided by 2 is 35 point, well, it would be 35.25, but we want to one decimal place, so we're going to go 35.3, and then 430.5 divided by 2 is 215, again 0.25, but to one decimal place, 0.3, so 215.3. So that are our first two values for theta. So now what we need to do is get the other solution from the graph. So remember what we're solving. I didn't draw my line on. We are finding where cos of theta hits the line y equals 1/3. So the other solution we want is this guy over here. Now by symmetry of the graph, this point is going to be 360 minus 70.5. Now 360 minus 70.5 is going to be 289.5. So that is this point here, 289.5. So what this gives us is another value for 2 theta. So 2 theta is 289.5. Now to get our next value, we add one lot of the period of cos onto 289.5. So 289.5 add 360, and that is going to give us 649.5. So that are another two values for 2 theta. So we now need to divide those two by 2 to get our values for theta. So 289.5 divided by 2 and then round it to one decimal, we get 144.8. And then if we do the same for 649.5, we get 324.8. So that are our 4 solutions to the equation. Good times. Okay, example 2, we want to solve cos of 4 theta equals 1/2 between minus 90 and positive 90 values of theta. So there's no funny business here, we don't need to rearrange the equation. So the first thing we'll do is change the interval. So we got cos of 4 theta, so we need to multiply the interval by 4. So we can get minus 360 is less than or equal to 4 theta is less than or equal to positive 360. So if we inverse cos of 1/2, we would get our first value for 4 theta is the inverse cos of 1/2, which is 60 degrees. So if we now sketch the graph between 0 and 360, cos looks like that, where that's 360 degrees, this guy is 90, this guy is 270. Okay, so we are solving cos of 4 theta equals 1/2. So on the graph then we are finding the points where the graph hits y equals 1/2. So we found our first value for 4 theta is this guy here, which was 60 degrees. So we got 4 theta is 60 degrees. Now, if we add one period onto that, 60 add 360 is 420. So that is out of our interval for 4 theta. But we have a negative part of our interval. So what happens if we subtract 360? We are going to get minus 300, which is in our interval for 4 theta. So that value is important. So here then are our first two values for 4 theta. So to get our values for theta, we divide them by 4. So we will get theta is 15 degrees and minus 75 degrees. So that are two values for theta in our interval, minus 90 to 90. So now we need to find this other point up here where the curve hits 1/2. So this is going to be at either 360 minus 60. Well, that is where it's going to be. So this is going to be at 4 theta equals 300. So that's the x value there, where cos of theta hits y equals 1/2, but that gives us our value for 4 theta. Now again, this comes from changing the interval. So we get then 4 theta is equal to positive 300. Now again, if we add 360 onto that, we are outside of our interval, but if we subtract 360, we get minus 60, which is definitely inside of our interval. So if we divide these two by 4, we get our other two values for theta. So 300 divided by 4 is 75, and minus 60 divided by 4 is minus 15. So that are our 4 values of theta. Good times. Okay guys, I think that'll do for this video. In the next one, we will do tan.